You know, for as long as we've looked up at the night sky, we've been dreaming about Mars. It's that next great frontier, humanity's next giant leap. But getting there, well, it isn't just one problem to solve. It's two, and they are absolutely colossal. And one of them is a lot closer to home than you might imagine. Let's dig in.
So, this right here, this is the dream. It's the goal that decades of work from thousands of brilliant people has been aiming for. Humans living and working on a totally different world. This picture from NASA, it's not just some sci-fi fantasy. It's practically a blueprint. But the road from our world to that one is filled with just immense challenges.
The amazing Ray Bradbury really captured the whole spirit of it, didn't he? This whole adventure is about so much more than just planting a flag. It's about figuring out our place in this giant cosmic fireworks show. But to make that beautiful, poetic idea reality, we've got to solve some incredibly tough, down-to-earth problems first.
And that is really what we're digging into today. NASA's own detailed plans reveal two huge, separate battlegrounds. On one hand, you've got the raw, brute force challenge of engineering, building the machine. And on the other, you have the delicate, incredibly complex challenge of the human mind. The machine versus the mind.
Okay, so first up, building the machine. This is the world of physics, logistics, and engineering on a scale that is honestly hard to wrap your head around. This is the nuts and bolts, hardware side of the equation.
I mean, just look at the numbers here, the sheer weight of it all. This table from NASA breaks down the mass for just the ship they'll travel in. And a huge chunk of that, look at that, is propellant fuel for the big burns to get into Mars orbit and then get back home. In total, we're talking about over 145 metric tons. That's insane. It's like launching, 25 large elephants into deep space. And every single pound costs an absolute fortune to get off of Earth.
And the level of planning is it's incredible. It's not just about getting there. It's about being able to stay there. This table here, it shows the gear they'll need to actually make fuel and other resources right there on Mars. And look at the power needed, 33 kilowatts for just this one system. It just goes to show how every single piece of this puzzle has to be planned out meticulously.
And there's actually a really cool name for this whole idea, In Situ Resource Utilization, or ISRU, and it is a total game changer. The idea is, instead of trying to pack every single thing you could ever possibly need for years, which is impossible, you learn to live off the land. You make your rocket fuel from the Martian air. It's really the only way a long-term human presence there is even possible.
So yeah, the engineering is absolutely breathtaking, a total masterpiece of human ingenuity. The machine? It's getting there. But that just brings us to the second and, maybe the harder problem. What about the human mind stuck inside that machine for years on end?
All right, section 2. Let's talk about the human factor. We're stepping out of the engineering bay now and into the world of psychology. Because the vast empty space isn't just outside the ship. It's something the astronauts have to fight inside their own heads, too.
So how do we even begin to understand this risk? Well, scientists look at the most Mars-like places on Earth, and that means Antarctic research stations. And the numbers they found, wow. In one study of people who wintered over, completely cut off from the world, a staggering 62.1% said they felt depressed.
And that's not all. In that same group, 64.1% reported having major problems with sleep. Now think about that. You're running a mission worth billions, where one tiny mistake could be catastrophic and your crew is exhausted. That's a dangerous situation.
And here's maybe the most terrifying number for mission control, 51.5%. Over half said they had difficulty concentrating or even remembering things. The very environment of the mission itself is actively working against the mental sharpness you need to survive it.
So all these individual stresses, well, they don't stay individual for long. Sooner or later, they start to bubble up and affect the whole team. A Mars mission is more than an engineering project. It's a high-stakes, no-escape social experiment.
And research shows this kind of thing happens in a pretty predictable way. At first, everyone's friendly, finding things in common, but they're also quietly sizing each other up. Then, before you know it, little cliques start to form, and eventually you get this dominant in-group that can end up pushing anyone who doesn't quite fit to the outside, which, as you can imagine, creates a ton of tension.
And look, this isn't just some theory from a textbook. A Russian cosmonaut, Valentin Lebedev, spent 211 days up on the Mir space station, and he figured that nearly 30% of his time was spent just dealing with crew conflict and arguments. 30%. That is a huge amount of drama to have when you're trapped in a tin can millions of miles from help. So,
If the environment itself is going to cause these issues, what do you do? Well, the answer starts way, way before launch. It's all about intense psychological screening. It's about finding the right stuff, not just for flying the ship, but for mentally surviving the journey.
And the whole way of thinking about this has had to completely change. See, back in the day, for short Apollo or shuttle missions, it was all about what they call select out. Basically, just screen people to make sure nobody has any obvious psychological problems. But for a 3-year trip to Mars, that's not going to cut it. You have to select in. You have to actively hunt for those very specific personality traits that tell you someone is going to be resilient and perform well under extreme long-term stress.
So what does that actually look like? Well, the right stuff from Mars isn't your classic lone wolf movie hero. It's someone who's super driven and independent, but also warm and sensitive to other people. They love a tough challenge. The wrong stuff, on the other hand, is that hyper-competitive person, the one who's arrogant or impatient. Those are traits that might get you ahead here on Earth, but they are pure poison in a tiny, isolated crew.
And this really gets us to the heart of it all, doesn't it? The real challenge here isn't just about building a better rocket. It's about building a better, more resilient crew. It's about finally realizing the final frontier isn't just out there, but it's also in here.
And the person holding all this together? The commander. Wow. The ideal Mars leader has to be this incredible mix of things. They've got to be super competent, a total pro, but also really sensitive to how their crew is feeling. They need to be flexible enough to be a hard-nosed boss one minute and a supportive counselor the next. They're managing the mission and the morale at the same time.
So when it all comes down to it, it's this. For decades, we've thought the right stuff was about being a brilliant pilot with nerves of steel. But the journey to Mars is teaching us that's only half the story. The real right stuff for this new era of exploration is a deep blend of hardcore technical skill and just unshakable psychological resilience.
Which kind of leaves you with this one big question, right? We are building these incredible, unbelievable machines to cross the millions of miles between planets. But what if the greatest, most difficult distance we have to travel to get there isn't the one across space, but the one inside our own minds?